Hi guys, welcome back to another lesson. In today's lesson we're going to look at tree diagrams and how to use tree diagrams to work out the different possible outcomes and also the probability of those outcomes. So let's just jump straight into it. So first let's look at how we use tree diagrams. So we're going to use the tree diagram on the right to answer some questions. So the first one is, how many possible outcomes are there in total? So if we go through, well, this one here, if we follow our chain of our tree, so we flip a coin and we either have an option of heads or tails initially. Okay, so for our first outcome, we've gone heads. So flipping it 4 times, the first time we get heads, the second time heads, third time heads, fourth time heads. So we get heads, 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 heads. This next one, we get heads, 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 and then a tail. This one here, we get heads, heads, tail, heads. This one is heads, heads, tail, tail. And so on until we get all of our outcomes listed. So this is a really good way of showing like the different possible outcomes that we could possibly get, the different combinations. Okay, and it can work for when you have a variety of or a large number of different possible outcomes, and we're going to look at that in the next example, or not the next one, the one after that. So in total, how many possible outcomes are there? Well, there's 16, so that's all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now it's important to notice as well, 16 is the number of final outcomes here as well, the number of final branches. So find the probability of flipping at least one heads. So what we're going to do first is circle or put a box around all the ones where we get at least one head. So we have to have one head. So the way I did this was I looked at which ones didn't have heads at all. Okay, and there's only one option that had absolutely no heads, and that's this final one. So if I'm looking for how many have heads, well, that's the other 15. So I get 15 out of 16. So the probability of at least one head equals 15 out of 16, which gives us a probability of 0.94. If we look again at least 2 heads, I want you to pause that, go and calculate the probability of getting at least 2 heads and then come back. Okay, so if we look at the possibility of getting at least, or the probability, sorry, of getting at least 2 heads, we have 11 possible outcomes with 2 or more heads as an option. So we have 11 out of 16, which gives us a decimal of 0.688. Now the next and final one is getting exactly 3 heads. So if we indicate the outcomes that have at exactly 3 heads, so that's no more than 3 and no less than 3, well, we have 4 possible outcomes, which gives us a fraction or a probability of, I did change that to 4 out of 16, but that's okay, we'll just change that quickly now. 4 out of 16. Which gives us a decimal or a probability of 0.25. So let's look at drawing tree diagrams and how we go about drawing them. Now you could do what I'm going to do, which is have little symbols, or you also could use letters. So a young couple, Tim and Sarah, begin to talk about starting a family. Tim decides he would like 3 children, 2 boys and a girl in any order. What is the probability of them having 2 boys and a girl? So we're going to use a tree diagram to help us answer this. Okay, so I'm using symbols. I'm going to use blue and a pink baby, but you could also just write B or G, so for boy or girl. So their first child is either going to be a male or a female child. Then if we go off our male, we're going to have, if we have a second child, so we had a male the first time and we're going for our second child, the possible outcomes are again either a boy or a girl. Now if we go, they've had a boy for their first child, a boy for their second child. Now they're going for their third child. Again, it's going to be either a boy or a girl. And we keep doing this until we've got our 3 rows all filled out. So here we have our boy and our girl. Then back over to here we have boy and girl, and boy and girl. So now I'm going to follow each branch of our tree diagram and write the possible outcomes down here. So the first outcome could be having a boy, then a boy, then a boy. So I'm going to write B, B, B for boy, boy, boy. The second one is boy, boy, girl. The third one is boy, girl, boy. And then boy, girl, girl. Then over here we have girl, boy, boy. Then we have girl, boy, girl. Then girl, girl, boy. And girl, girl, girl. So what are the probabilities of having two boys and a girl? So let's go through and find all of the outcomes that are two boys and a girl. So we'll start with the total number of outcomes, which is out of 8 possible outcomes. So the probability of 2 boys and 1 girl, so there's 1 outcome, 2 outcomes, 3 outcomes. So there's 3 possible outcomes out of the 8. So the probability of getting 2 boys and 1 girl is 0.375. So let's look at another example. So this is when there's multiple possibilities. So if we go back to our boy and girl, each time there was only 2 possible outcomes. It was either going to be a boy or a girl. But what if there are multiple outcomes that we could obtain? So Nick wakes up to find that his power is out. He decides that he is going to get dressed in the dark. He knows he has a pile of clothes at the end of his bed, so he just grabs an item at random. In the pile there is a yellow, green and orange shirt, blue and grey pants and orange, green and red shoes. What is the probability that he is wearing a green shirt and red shoes? So we're going to draw a tree diagram to represent this. Now because there's multiple items and we're talking about colours and the colours are occurring within different items, like we have a green shirt and green shoes, we can get a little bit confusing. So using symbols can be quite helpful. So we have our male, what did I call him again? Nick. So we have Nick here. Now, the first thing he grabs is a shirt. So there are 3 possible outcomes. It's either going to be yellow, green or orange. So say he was to grab a yellow shirt and then he grabs some pants. From that, it's either going to be a grey pair or a blue pair of pants. Now say he grabs the grey pair of pants. There are 3 options for our shoes. They're either going to be orange, green or red. Now we do the same for each branch. So then we go back to our pants and we do our 3 shoes. Our green shirts, we do our 2 jeans or 2 pants, our 3 shoes, and then our orange shirt is 2 pants and 3 shoes. Now you might need to pause this so that you can add these diagrams into your notes. So let's put our combinations together. How many different outcomes? So yellow shirt, grey pants, there are 3 outcomes because you could have 3 different pairs of shoes. Same with the blue, 3 outcomes. And we just keep going till we fill all of our outcomes. So the question was, first the total number of outcomes. So 3, 6, 9, 12, 15, 18 possible outcomes. So what is the probability of getting a green shirt and red pants? So green shirt means we're just looking at these outcomes here. And the outcomes that are green shirt and red shoes are these 2. Now it doesn't say what colour pants, so it doesn't matter. So the probability is 2 out of 18 or 1 out of 9, which gives us a decimal of 0.11. That's it guys, thanks for watching, and remember if you have any questions, please make sure you ask. I'll see you in the next video. Thanks guys.